Have you ever wondered, are we alone in this vast universe? Don't worry, this isn't just some silly question that pops into people's heads while staring at the ceiling at night. Scientists are researching this day and night. Today I'm going to talk to you about whether there is life in space. Hundreds of movies have been made about this, and in all of them, aliens are depicted as having large heads, green skin, and big eyes. First, let me explain the reason for this. The reason we imagine aliens with green skin is the assumption that they photosynthesize just like plants, though that is actually a very inefficient energy source for constantly moving creatures. Of course, if you're an alien who loves leisure and sunbathes all day, why would it be bad, right? Jokes aside, scientists have recently been accelerating their search for extraterrestrial life within our solar system. For instance, it was discovered that there used to be water on Mars, and we were very hopeful that life might exist there. They even found formations known as leopard spots. These could have been the remains of bacteria that lived in that water. But were those bacteria still there? And were they truly bacterial remains? It's a highly debated topic, but if a living organism once existed there, discovering it would be a groundbreaking event. However, scientists have better candidates, not a planet, and certainly not an alien asteroid, but Europa, a moon of Jupiter, the king of planets. Many of you might be surprised to hear that. Isn't Europa a continent on Earth? But it is also the name of a moon. We discovered geysers on Europa. Yes, there was water, but why couldn't we see it on the surface? The reason lies in the layer of ice, which acts like a blessing for any potential life forms, shielding them from Jupiter's radiation storms, assuming, of course, that life exists there. And recently, carbon dioxide. An outflow was also detected. This could be a sign of something breathing there. But how do we know for sure that they need to breathe, or even that they are carbon-based life forms? Still, Europa remains a fantastic candidate for us. I can almost hear you asking, if there is life there, why don't we just go and take a look? Well, you're actually a bit late. NASA has already launched the Europa Clipper probe. It lifted off successfully from the Kennedy Space Center in 2024, and we are now awaiting its arrival in 2030. You're getting impatient, aren't you? Rest assured, you're certainly not the only one. Scientists are quite excited too. In fact, we might well find life in the vacuum of space. During an ISS mission, astronaut scientists released some tardigrades and other life forms into space, and the results were amazing. They survived. If life forms that evolve for Earth's conditions can survive in space, imagine what might exist if life evolved under harsher conditions. Creatures with pressure-resistant bodies or organisms that generate energy in entirely different ways. Thinking about it this way probably brings strange creatures to mind, doesn't it? Yet, as wonderful as those dreams might be, 99.9999% of what we hope to find is bacteria or single-celled life forms. Personally, I think that's for the best. Just imagine your spaceship being overrun by Martian maggots. That would be terrible. But joking aside, discovering a complex multicellular organism would be incredible. Scientists could study them and truly broaden our horizons. But consider this. What if we found life, or even just a sign of it, on planets orbiting Proxima, the nearest star? Do we have the power to get there? It's 4 light years away. That means taking 300,000 kilometers and multiplying it by 60, then 60 again, then 24, then 360, and finally by 4. That's a massive distance. Is there anyone brave enough to travel that many kilometers, roughly 3.73 times 10 to the 16th power kilometers? I doubt it. Even if we traveled at our fastest speed, say aboard the Parker Solar Probe, it would take 6.7 million years. If anyone has a lifespan long enough for that, you can pick up your tickets at a NASA dealership. That was a joke, of course, but what about life in other dimensions? What if we opened a dimensional portal? Well, buddy, it doesn't work like it does in sci-fi movies. These dimensions exist at the subatomic level, and shrink all you want, you still won't get through. One of the questions that crosses people's minds is this: what if aliens are watching us from afar? I mean, if they have the technology to watch us, Well, what can I say? Good luck to them and happy viewing. I can hear you saying, but what if we opened a wormhole and teleported? Yes. If we look at Einstein's widely accepted theory of relativity, it is quite possible. In fact, a simulation was recently run on a supercomputer where a cube was passed through one. I can also hear you saying, why are you spouting nonsense? You're explaining it like I'm an idiot. Let's just open one and go. Hey, watch your tone. Just kidding. But to open that wormhole, we need exotic matter. Exotic matter is matter with negative mass. Normally, when matter clumps together, it creates a gravitational field that pulls everything in, but negative matter pushes things away. Imagine placing a heavy marble on a piece of fabric. It sags. The fabric of space-time is just like that. But imagine placing a marble down and instead of sinking, the fabric rises into a tiny mountain. Wild. Yet we need this because if we use ordinary mass to bend the fabric of space-time, it collapses in on itself and forms a black hole. To prevent that, we sprinkle a little exotic matter around and bam, the wormhole is ready. For now, though, this is no different from science fiction to us. Who knows? Maybe one day when we become a Type 2 or Type 3 civilization, this technology will take over the job of our subways. Take care of yourselves. If you enjoyed this, please like and subscribe. But if you've watched this far, go ahead and open a wormhole right on that like button, and bye-bye.